Good morning, class. Today we're going to be going over lesson 6.9, where we'll be talking about angle similarity. Remember, we say two triangles or two figures are similar when they have a dilation that can be performed to go from one triangle or one figure to the other. Today we're going to be specifically talking about triangles, and we're going to learn a theorem or something we can use to prove that two triangles are similar. So similar, remember, we say figures are similar if you can perform a dilation to get from one figure to the other. And here's the angle similarity theorem. We say two triangles are similar if they share two common angles. This is because if triangles have two angles in common, they also have to have the third angle in common. And if triangles have all three angles in common, then you could perform a dilation to go from one triangle to the other. So if you guys need to get this notes down here, make sure you pause the video to get these definitions down. And let's get into some examples. So notice these two triangles. We have these two pairs of triangles. We have one pair on the left and one pair on the right. So notice with this pair on the left, both of these triangles have angle measurement 40 degrees on the left here and 60 degrees on the right. They both have a 40 and they both have a 60. So notice if we did 180 minus 40 minus 60, I would get 80 degrees, I believe. 80 degrees. And if we did the same thing over here, 180 minus 40 minus 60 degrees, we would get 80 degrees. So it turns out that these triangles have all three angles in common. They're all 80 degrees. But you only need two to prove it, because if you have two in common, then the third one has to be in common. That means that triangle AEB is similar to triangle CFD. They're similar because you can perform a dilation to go from one to the other. Now, we can't show what that dilation or that scale factor is because we do not have the measurements of these side lengths, but since we know the angle measurements, we can say they are similar. Now let's look at this triangle over here, triangle ACB and triangle XZY. All right, so these triangles are also similar because they have this corner B and this angle Z are in common, since they both have one ring around them. And angle A is the same as angle Y, since both of these angles have two rings around them. And that means that triangle ABC is similar to triangle YZX. All right, they are similar to each other because they have two angles that match up. And that's really all we need to prove that two triangles are similar. Alrighty, let's go on to our next slide here. Are these triangles similar? So we have triangle PQR and triangle STU. So what we have to do is we were going to have to find the third measurement of one of these triangles. Notice how we know two of the degree measurements, but we do not know the third. But we can find the third. Let's call this measurement R right here. So we know that 100 plus 45 plus R is going to be equal to 180 degrees because all of the interior angles in a triangle will add up to 180 degrees, which means 145 plus R is equal to 180 degrees. And when we subtract 145 from both sides, we're going to get R is equal to 35 degrees. So at this point, we could stop because we do have two angles in common. I have angle Q, which is 100 degrees, and angle T is also 100 degrees. And then I have angle R, which is 35 degrees, and angle U is also 35 degrees. Now, if you want to be really diligent here, we could find out what angle S is. So what angle S is, we could do the same thing we did on the left. We could do 100 plus 35 plus S is going to be equal to 180 degrees, which means 135 plus S is equal to 180, or after subtracting 135 from both sides, we get S is equal to 45 degrees. So it turns out that these do indeed, in fact, have all three angle measurements in common, so they are similar, but we only ever needed to find two. We needed to get our angle similarity down. So yes, these two triangles are similar. All right, next question here. Are these triangles similar? I have one with 41 degrees, I have one with 30 degrees, and then our other one is 109 degrees and 30 degrees. So how about we find the missing angle measurement right here? Let's find angle B. So we should know that 41 degrees plus 30 degrees plus B is going to be equal to 180 degrees, because if you add up all the angles in a triangle, they will sum to 180 degrees, which means 71 degrees, or 41 plus 30, plus B is equal to 180 degrees. So by subtracting 71 from both sides, we're going to get B is equal to 109 degrees. So now we just have to find out if we have two angles in common. Well, I have this 30 degrees here. Obviously, these are the same. They were given. And then since both of these triangles have 109 degrees right there, then yes, these two triangles would be similar to another. Triangle ABC is similar to triangle DEF. And if we wanted to further prove this, we could do 180 minus 30 minus 109, which is equal to 41. So they actually do indeed have all three angles in common. All right, triangle ABC was dilated and rotated to form triangle DEC. And we want to find the length of this side AC here, our little variable x. So what we want to find out is we just want to see which side lengths we have to multiply by to get to our new side lengths, right? Because remember, if triangles are similar, that means you could perform a dilation to go from one to another. And since this is just dilated and rotated, yes, these two triangles are similar. So what we're going to do is we're going to take our new side length and our old side length and put them over one another, okay? So we're going to put new over old, or 5 over 8, and that should be equal to our other side length here. So on this one, our side length is 6, is our new one, and x is our old one. Now, you may be wondering how I knew that which side lengths paired up with one another. For example, how did I know 6 paired up with x and 5 paired up with 8? Well, the reason is because I just knew that we dilated, we got smaller. It told us ABC was the original, so I know this is the old one up top here, which means this one has to be the new one. And then since it was rotated, I know we're going diagonally here. All right, so now we're going to have to cross multiply, and then we're going to be able to solve for x. So we're going to do 5 times x. 5 times x is 5x, and 8 times 6 is 48. So 5x is equal to 48. Now we simply have to divide 5 on both sides, and we're going to get x is equal to 45 divided by 5 is 9, 9 and 3/5. 9 and 3/5, I believe. Let's double check that, though. 48 divided by 5 is equal to 9.6. Good. So what is the length of side A, or side AC here, which is length x? It would be 9 and 3/5, or 9.6 degrees. 9.6 or 9.6 units rather. Alrighty, everybody. We have one more slide left, I believe, before questions. Nope, we're going right into questions. Here we go. These triangles are similar. What is the measure of the missing angle? So we have to find the measurement of the missing angle right here for both of them. So on this problem we should be doing, we notice that we have 2 out of the 3 measurements in our triangle, which means 180 degrees is going to equal to 93 plus 47 plus, let's just call it x. It's 180 is equal to 140 degrees plus x, which means x is equal to 40 degrees. All right, let's get on our next slide here. Are these triangles similar? If yes, what is the measure of angle A? This one right here. If they are similar, then obviously they are similar, and then you want to find the measurement of angle A. All right, so on this one here, we can solve for angle A first. So angle A we can find by doing 180 is equal to 35 degrees plus 90 degrees plus A, which means 180 is equal to 125 degrees plus A. By subtracting 125 from both sides, we get that A is equal to 55 degrees. 55 degrees. This one right here. So yes, they are similar because we have 2 in common. We have the right angle, this right here, is congruent with that. They are the same. And then the 55 degrees is the same as our 55 degrees down here. So yes, they are indeed similar. And angle A is equal to 55 degrees. These two triangles are similar. If we go from triangle ABC to triangle FED, what is the scale factor? So they're similar. Find the scale factor. This would just be like performing a dilation. So remember, whenever we perform a dilation, we have to take our new side length divided by our old side length. The only thing we have to be careful about here is that we are matching up our sides correctly. Notice how my 80 degrees, that must be the same, and that one is on top. So what we want to do here is we want to find the side length to the left of my ADC, or excuse me, the left of my 80 degrees, which is this side length 5. And then also to the left of my 80 degrees over here on triangle ABC is 2.5. So since ABC was the original and FED was the new one, we need to put our new side length over our old side length, which would be 5 over 2.5. Our new is 5, our old is 2.5, and 5 divided by 2.5 would be equal to 2 degrees, or 2. So that means 2 is the scale factor here. Alrighty, we have one more question for us here. If these triangles are similar, what is the measurement of EF down here on the bottom? So we're assuming these triangles are similar. We want to find out what EF is. So the good thing we can do here, the first thing we want to do is find our scale factor. Let's take side length DE and side length AB and use those to find our scale factor. Remember, to get our scale factor, we need to do new divided by old. Here, the new side length is 24. This one right here, so we do 24 divided by our old is 8. 24 over 8. 24 divided by 8 is 3. So that is our scale factor. Now, to go from side length BC to side length EF, we have to multiply by that same scale factor, right? So since side length BC times our scale factor, 3, should be equal to side length EF. Since side length BC is 6, we need to do 6 times 3, which is equal to 18, which is why 18 is the length of the scale factor, or excuse me, 18 is the length of the side EF. Alrighty, everybody. That was it for us today. So make sure you guys are writing 2 complete sentences about what you learned tonight, 2 complete sentences. If you guys have questions on this, I will see you in class tomorrow. Have a great rest of your day, everyone. Peace out.